Hello. This module that we'll be going over here on the production function has several videos. And the main production function that we're going to be spending a lot of time on is the Cobb-Douglas production function. And the reason why is because it has constant returns to scale and diminishing returns to capital and labor. So this production function, reason why we're interested in a production function is because we need it for the subject of growth. And for the most part, the production function just shows the mathematical relationship between inputs and outputs in the economy. The output in the economy is real GDP. What are the inputs? We want to know what that relationship is between inputs and outputs. We add more inputs, we get more output. So the main one I said we'll go through is this Cobb-Douglas production function, which was developed by about 100 years ago. And guess who came up with the Cobb-Douglas production function? Two guys. One named Cobb and the other named Douglas. Charles Cobb and Paul Douglas. Okay. So away we go. Okay, here's the outline on the production function. And we're going to spend time on the Cobb-Douglas production function, which has diminishing returns to scale. Constant returns to scale. And diminishing returns to capital and labor. Then we'll go through the marginal product of capital labor. And the share of income that goes to labor and the share of income to people that hold capital if the entire economy is perfectly competitive. Okay, this mathematical relationship between inputs and outputs can be written as output, Y, real GDP, is some function of inputs. So we can write this generally as Y is some function of those inputs, which are capital, K. So K is capital. And when I say capital, I mean like physical capital. It could also be software too, which really isn't physical, but we'll put it in the category of capital. Labor, L is labor, which is workers, unskilled workers. But you got to give those unskilled workers some skills, and that is human capital. So HC is human capital, which are the skills that workers have to do their job. And A, which is really everything else, but includes technology. We say A is technology. We don't use T because T is already taken up for taxes. That's the biggest category inside A is this technology, but it really includes everything else other than capital, labor, and human capital. A is referred to as total factor productivity. Total factor productivity, which is essentially everything else that makes workers more productive. So graphically, we can describe this as, well, if we use the aggregate demand, aggregate supply curve, the long run aggregate supply curve, remember, is vertical. And on this axis, we can put price or inflation. And it's vertical at potential output, which I'll write as Y superscript P. So real potential output. And if we add more inputs, there should be more output. And that'll shift the long run aggregate supply curve to the right. So we add more people, we should be able to produce more, which increases our potential output in the economy. We can also graphically describe this with the PPF, the production possibility frontier. So here is the PPF, which shows our potential output, the different possibilities of our potential output. And any of these things, inputs in the production function, is going to shift that PPF out. So same thing. If we have more people, more capital, more human capital, more technology, any of these things, it will push this PPF, or production possibility frontier, outward. And remember, the main reason to understand this production function is so we can understand growth. We want to know how countries grow. And we can represent growth by shifting out of this PPF or by the long run aggregate supply curve moving to the right. The Cobb-Douglas production function is written as y equals a times k to the alpha times L to the beta power. So real output y equals A, which is total factor productivity, times capital to the alpha power times labor to the beta power. The exponents, alpha and beta, are each greater than 0, but less than 1. So each is greater than 0 and less than 1. And together they add up to 1. So alpha plus beta equals 1. That gives us what we want. It gives us constant returns to scale and diminishing returns to capital and diminishing returns to labor. Now, economists have tried to estimate what is alpha actually and what is beta. And estimates are alpha is somewhere around a third, put it this way, a third to a quarter, somewhere in this range. And beta, what's left over, somewhere around 2/3 to 3/4 by the empirical estimates. Now this Cobb-Douglas production function shows constant returns to scale, CRS. Constant returns to scale means you double all inputs and you double all outputs. Triple all inputs, you triple the outputs. So if we have something like y equals a times k to the 1/3 times labor to the 2/3, the 1/3 and the 2/3 add up to 1, and that will give us constant returns to scale. We can show that it's constant returns to scale by just figuring out, well, what if we double capital and what if we double labor? Those are the inputs here. What will happen to output? Well, if we double capital, our inputs will be a times 2 times capital to the 1/3 power. And if we double labor, we'll have double the labor, or 2 times L for labor, to the 2/3 power. And that would be equal to a times 2 to the 1/3 times k to the 1/3 times 2 to the 2/3 times L to the 2/3. That's equal to a times 2 times k to the 1/3 times L to the 2/3. So 2 to the 1/3 and 2 to the 2/3 is 2 to the 3/3, which is 1. And that's equal to 2 times A times K to the 1/3 times L to the 2/3. Now remember, A times K to the 1/3 times L to the 2/3 is Y. And 2 times that would have to be 2Y. So here's the proof of showing that we double capital, we double labor, doubling all inputs, and we get double the output. And we can easily check for that by just adding up the exponents in this production function, the 1/3 and the 2/3, and it equals 1. Now this production function also shows that there's diminishing returns with capital. As long as alpha is less than 1, we'll have diminishing returns to capital. Now if we draw output on the y-axis and K on the horizontal axis, if alpha is less than 1, we'll get a shape that looks kind of like this. Be rolling over a little bit. It gives us the shape we want for diminishing returns, which means that as we add capital, holding everything else constant, we hold labor constant, we hold A constant, total factor productivity, and we just change K, output will increase, but by a decreasing amount, decreasing rate. There'll be diminishing returns to capital. So we'd be able to write this as something as y equals some constant times, say, K to the 1/3 power, if alpha is A, and the graph would look something like this. The slope is positive, but decreasing. Now, if we change labor, increase labor, then we'll still get a curve that looks like this. It'll just be higher. So the first curve in blue was some fixed amount of labor. We'll call it L1. Some fixed amount of total factor productivity. We'll call it A1. And if we were to increase labor, we'll say labor is L2. We won't change technology. We should be able to produce more output with more labor. But we'll still have this diminishing returns to capital. So we can see here this diminishing returns. I'll put this in, say, black. We can see the slope of this is decreasing. So right here, the slope is something like that. Over here, it's something like that. So the slope is positive, but decreasing. The slope is called the marginal product of capital. So the marginal product is the change in Y over the change of K, marginal product of capital, or partial Y, partial K, which is greater than 0. And the second derivative will be less than 0 because of the diminishing returns. Now take a look at this. Let's say at this level of K, we can see what the marginal product of K is. It's just that slope of that black line. What happens if we add labor? Well, we move up to the red curve. And what's the slope of the red curve at that point? Well, it's kind of like that. Now, if I've drawn this right, the slope of the blue line is a little bit steeper than the slope of the red line. So over here, this is steeper, which means the marginal product of capital is higher. So higher marginal product of capital here on this one. Just like you can see that between these 2 points, the marginal product of capital is decreasing. When we move up on the next curve, the red curve up because of adding labor, the marginal product of capital, which is the steepness of that slope, keeps getting a little bit steeper. We add more labor, even more labor. Take a look now at the marginal product of capital. See, that slope is much steeper than before. So that means that the marginal product of capital is increasing. So with any fixed amount of labor, the marginal product of capital shows diminishing returns. And is decreasing. It's decreasing because it's showing diminishing returns. As labor is added, L, the marginal product of capital increases. So if you want to know what the marginal product of capital is at any one point, just look and see what the slope of that curve is. And the steeper it is, the higher the marginal product of capital. Now we can do the same thing for labor. If we hold capital constant and total factor productivity constant, and we put labor down here on this axis, we can draw the relationship here. And the reason is because beta is less than 1. And we will find that the slope of this line, the marginal product of labor, is decreasing as we add more labor. So this is holding capital constant. Put a bar over it so it's a constant. And A is constant. And this would mean that partial y partial L will be greater than 0. And the second derivative with respect to L will be less than 0. Mean that slope is positive, but it's decreasing. So marginal product of labor, it's a slope. It's a change of y over the change in L. And that is marginal product of labor, or partial y partial L. And as the marginal product of labor, as more labor is added, let's put it this way, as labor increases, that means the marginal product of labor is decreasing. And if we add more capital or total factor productivity, we can see what's going to happen. Just like in capital, we'll say we add some capital here, some fixed amount of capital that's higher. We'll call this K2, where K2 is greater than K1. At the same amount of labor, you'll be able to see that the slope is higher, meaning the marginal product of labor is higher. So as A increases or K increases, then the marginal product of labor increases. Okay, so what we did in this video is we went through production functions, particularly the Cobb-Douglas production function, and what constant returns are to scale and diminishing returns. So this is why economists like the Cobb-Douglas production function. It's got diminishing returns to capital and labor, and yet it has constant return to scale. In the next video, we'll continue on. I'll show you a little bit about how the marginal product of labor is the demand curve for labor, and how we can get this share of income and capital by looking at the production function.